Okay, cool. Hi everyone, my name is Arham, and this presentation is called The Realist Assumption in Developmental Psychology. And one of the things that, just before we get started, is the majority of the presentation is really about psychological methods. And I'm hoping that you'll see it pay off at the end and how it features in education, but just so that I don't lose interest, a really brief picture of that is that we often import a lot of stuff and how we think about children in particular from psychology and psychological methods. Think, for example, the very standard account that children are incapable of reasoning until they're sort of 7, 8, something like that. And generally what this paper is really about is certain inferences that are made in psychology, and this assumption I'm calling the realist assumption, which is not a good assumption. So I want to start with this general idea of what is developmental psychology. And the reason I want to start with that is because, one kind of picture is developmental psychology is just a discipline that asks certain kinds of questions. And I'm not sure how many people have read Rousseau's Emile. It's a big, false head text. But you're like, well, Rousseau asked those kinds of questions a long time ago, right? So questions like, how do we change as we grow older? What kind of experiences in our childhood affect us? What kind of early interventions produce long-lasting change? And the suggestion I want to make is that the questions aren't what make developmental psychology distinct. They're certainly part of it, the domain, but it's really, psychology sees itself as, the reason it's like Rousseau is not a developmental psychologist. For most developmental psychologists, it's because it distinguishes itself in the methods it employs. So there's something about the methods of psychology that is worth taking seriously in its disciplinary identity. And this is by no means a robust kind of or a comprehensive list of the methods, but here are some of the things that you see in a familiar picture of developmental psychology. You have these kind of experiments, where sort of, you put some babies in group A or group B, or you have children. Sometimes they're naturalized experiments where they do it in natural settings. And really, developmental psychologists rely primarily on behavioral observation. There are some exceptions to this I'll get on to later. And from those behavioral observations, there's sort of a causal account. So, babies in group A do this, babies in group B do this. Why do they do this? What's happening cognitively? And the developmental psychological account is one that then looks at postulating these kind of cognitive mechanisms, these causal accounts of what's happening behind the scenes that we can't see, that explains the behavior. And generally, when you add enough conclusions from developmental psychology together, you get this kind of rich picture of cognitive architecture, what's happening in cognition more broadly. So that's kind of the generic picture. And of course, when I'm talking about the assumption of developmental psychology, I can't talk about all developmental psychology, so I picked a fun subset, which is called Math Cog, by those in the know, or Mathematical Cognition. And Mathematical Cognition is this kind of cool discipline that originated in the 70s. For the purposes of my argument, it doesn't matter, I think, whether or not I'm talking about Mathematical Cognition. But there's almost no way to generally talk about this argument without a case study. So some questions that Mathematical Cognition asks is, how do infants acquire an understanding from numbers? When in development do more complex numerical abilities develop? Is this understanding innate? How do non-humans process numerosity? And incidentally, mathematical cognition, especially in the last 15 years, has had the most import in education, which is also why I picked it, because I thought it's interesting, math pedagogy in particular. Okay, so that's generally the kind of questions it asks, which begs the question, what are the kind of views in mathematical cognition? So Gelman and Gallistel are these two psychologists that really pioneered the field, and one of their main kind of, if you could summarize what their basic argument is that when children engage in behaviors construed as mathematical, and what is a mathematical behavior? We can talk about that later, but behaviors like counting, they are guided by, crucial, certain innate principles, also crucial. And a variant of this that comes up in that literature is that children have some prior understanding of fundamental concepts when they engage in mathematical behaviors. So I'll get to the innateness part and the guided by part later, but what are these kind of principles, right? So Gelman and Gallistel think that we're all born with these principles, these 5 in particular: one-to-one correspondence, stable order, cardinality, abstraction, order, and relevance. And as we grow older and we interact with the environment, you have the right kind of teaching, those principles kind of get exemplified or get realized. But really what explains our use of mathematics, our ability to, let's say, do counting, is the existence of these principles. Okay? And now you get the idea, how do they say that, right? How do you get that account at all? And I just want to point to, in the actual paper I go through a bunch of examples. For the purposes of this presentation, I'm just going to go through 2 brief ones. The first one is the one-to-one correspondence principle. So again, out of the 5 ones, it's the first one. It's the one that I think we all have. babies have it as well. Again, these principles we have, but even babies have them, but they're not yet realized, right? So they're just kind of there, whatever that means, and we'll get to that later, but they're there. So what does one-to-one correspondence mean? So one-to-one correspondence generically means the ability to correspond one numeral in a counting sequence to an object, right? So one of the main ways that they test this, and Piaget came up with these, who's the developmental psychologist of the 20th century, is by taking kids and seeing whether or not they can assign a verbal token to a particular object, and then another verbal token to a different object. So you're presented with like two things, like these two things, and if you can say and b consistently, or k and ch, or wah and meh, or 1 and 2, if you're like if you're like a super baby or something, then you can then you basically succeeded in the one-to-one correspondence. That's great. And Gelman and Gausel think that's evidence that you have the one-to-one correspondence principle that's guiding your ability to do that, because that's what explains it, right? Now, the verbal token task doesn't explain this kind of previous claim that these principles are innate, because remember, small babies can't make sounds, or they can make sounds, but they can't speak. And so most of these experiments have to do with 2- and 3-year-olds. And so then that raises the question, how do we know we're born with them? How do we know that they're innate? And one of the kind of pioneering things in developmental psychology is eye tracking technology. You can basically strap these on infants, and you look at their eyes. And one of the Karen Wynn's big eye tracking experiment from the 80s is one which basically is you take a screen and you present a baby with an object, and then you take away the screen, and you take the same object again, until they get kind of bored. And their eye, and the boredom is inferred through how long they're looking at the object. Then you get a different object, and you present that. And if the babies look at that second object for a longer period of time, that means that they were able to distinguish the first object from the second object. And that means that they were able to assign a unique identity to both objects, which means that they have the one-to-one correspondence principle. QE. So anyway, so that's basically testing for nakedness. Now, the principles conception is not the only conception, obviously. It was the first one, it was the most popular one in the end of the 20th century, but since then we've had alternative conceptions. The most popular one right now is probably Susan Carey's, and Susan Carey basically argues that this principal dog is wrong. It's silly, it doesn't really make sense, it doesn't capture a lot of the features we think you want to capture in an explanation. And she basically argues that there's actually two things that are happening. There's this thing called the approximate number sense that all animals are born with. That's your ability to distinguish between small numbers, like 2 and 5. So if a dog sees like 6 pieces of kibble and 20 pieces of kibble, if it goes for the site, it's because it has approximate number sense, not because it's engaging in arithmetic procedures, right? But for more complex mathematics, like algebra, it's much more like integrating systems of representation with the ability to use external symbols. It's much more tied with language, learning, and placeholders. Nunes has this view, which is a minority view in the literature, that these are not innate qualities at all, that really most mathematics is a combination of our ability to perceptually discriminate between objects, which is what the baby's doing. It's not employing some principle, it's not using ENS, it's just saying, can recognize that this is different from that, and that's all it's saying. Plus, this kind of view about human imagination and conceptual methods, which we're not going to get into. But the main thing I want to get all of you to think about is that, so far, is that so we have the same experiments, the one-to-one correspondence one and the eye tracking one, and we have different, I'll start by saying frameworks, which is Gelman and Gaussel's principles framework, Carey's ANS and systems of representation framework, and then Nunes's framework that talks about perceptual discrimination. And all of them are claiming these mutually exclusive things. All of them are claiming that what's happening cognitively, causally, are actually different procedures. Carey thinks that it's systems of representation, not principles. Gelman and Gaussel thinks it's principles, not system of representation, and so on. So there's a mutual exclusivity to these things. Okay, and this kind of already foreshadows the problem that I'm talking about right now. Right, so we begin with this process, what I call classifying behaviors. What counts as one-to-one correspondence is an example of what it means to classify a behavior. If I say, if the baby can assign the remote to this kind of sound, and I say that that's the baby doing one-to-one correspondence, that's me forming a classificatory scheme for what the behavior is. And we're moving somehow from that classification to this kind of causal claim, which is the baby is employing their one-to-one correspondence, or the baby has a system of representation that they're exploiting to do one-to-one correspondence, or the baby is using sort of conceptual mappings from the human imagination. And that applies to kind of all these accounts. Which begs the question, how do we get from thing A to thing B? And what I want to argue is that that's where the assumption comes in, that I will be critiquing. Okay. How are we doing? All right, good. So before going on to the assumption itself, I want to talk about some features of, again, here I was talking about classification and the causal explanation, so I want to start by talking about some features of what it means to classify something and what's distinct about classification. So in the paper I said kind of formally, which is what they're really saying is that certain behaviors B can be classified into distinct categories C, which reflect in principles B. And I want to focus on these three features of classification here. The first one is that classification involves partitioning into classes. And what that basically means is certain behaviors can be classified under the same category counting as alike. Right? So, you know, if you decide to kind of say 1, 2, 3, 4 over here, and a baby decides to say sort of look at one thing, another thing, by calling both of those things counting, I'm effectively drawing it, I'm saying you're doing the same activity, effectively, right? And by virtue of that, there are things that don't count as counting, right? So, you know, if you just pointed at something and you said that's a chair, I wouldn't say that's you counting one chair, that would be a distinct kind of activity. A feature of classification is that it's pluralistic, and this is very, very important, and we'll get to, like, I'm foreshadowing that causation is not pluralistic, but there's a variety of ways in which you can classify behaviors or phenomenon, and one example I'll just give, especially in science, is like planets. You know, Pluto was like, in our lifetimes, I think it's been demoted as a planet a bunch of times, and then it's re-promoted. And you're like, why, right? I think a lot of people are like, well, what's going on? Why is it getting promoted and demoted? And part of the reason was that NASA and other space agencies were playing around with the criteria of planethood, because it was either becoming too expansive or too narrow, right? Now, if you ask the question, what's a real planet? Like, what's a true definition of a planet? You'd be like, that's a strange question, because, you know, it's kind of what we decide on what a planet is. And then the second point is that how do we decide on what a planet is? Well, there are certain kind of use conditions for what counts as planethood. And I'm specifically talking about when we formulate definitions. I'm not talking about like everyday colloquial language, by the way, in which I know it's a lot more complicated. It's not always like usefulness. That's the determining principle. So once again, if we go to planets, you deliberate on a useful conception of planet. Same thing with species, right? Once genetics, we like discovered the double helix. Not we, like I wasn't involved, but you know, human beings discovered the double helix. You know, you come up with a different conception of a species as well. And part of that is, well, it's more useful now, it's more pragmatic. This is different from the causal claim, right? So the classification claim was saying that we can classify behaviors into categories, like the principles. The causal claim is saying that the principles have a causal role in producing the behavior. So it's talking about what's happening, so to speak, behind the scenes, in the baby's head, or in the child's head. And two features of the causal claim is that A, it involves the description of a procedure. So it's no longer saying this is the kind of way to think about what the baby is doing, what the child is doing. It's saying that they're guided by the 5 principles, or they're invoking systems of representation. It's something that the child does, right? It's like there's verbs. It's something the child does. It's a procedure the child's engaged in. And crucially, it's non-pluralistic. So classification, you know, what's a real planet? Well, you know, we can discuss it. What's actually happening cognitively? That's not you know, depends on what the most useful conception is. It's non-pluralistic, and it admits of truth and false conditions, which is precisely what the dispute is about. They say it's principles, not systems of representation, and so on. Now, how do you get from the first one to the second one? That's the assumption. So the assumption's a mouthful. I'm going to read it out once and then explain kind of what it means in the context of the paper. So if certain behaviors B can be classified into category C, reflected in principles B, it is sufficient evidence that the principles have a causal role in producing the behaviors. It's really just an if-then clause with the classification and causation. So it's saying if we can successfully classify effectively, then we can legitimately infer these kind of causal explanations. And again, one alternative way to say it that's less formal, I guess, is if children's behaviors answers to certain schematizations and they do so effectively, the behavior is explained by the implicit invocation of the schematizations. Okay, so two features here that I wanted to talk about briefly. One is that the realist assumption takes our systems of classifying behaviors to mirror the underlying causes that produces those behaviors. And what that means is that it's not only that we are saying that, looking at a behavior and saying, hey, this we can think about this as one-to-one correspondence. But if we can, let's say, trace some kind of regularity in, we find that this is a good activity that a lot of babies can do and they do so consistently and stuff, then it must mean that there's a mirror kind of cognitive procedure that's the invocation of the one-to-one correspondence. That's what this mirroring is. And the second thing is that it's a cognitive mechanism. It's something, and again, I use words like implicit, unconscious, because that's what I'm quoting words like implicit and unconscious because that's what they argue, right? They have to explain why the baby is doing this without being aware of doing it, right? And so the way they do that is by using words like implicit, unconscious, subconscious, without knowing, right? And that's something that the children are doing. And the last thing I want to say, which is sort of a caveat, is that the realist assumption is not, I'm not saying it's made by psychologists proactively, but I'm saying it's required, right? So either they can't make the jump from the classification to the causal claim, or they want to, in which case they have to make this assumption. So the assumption's kind of there either way. It's like either you have to make it if you want to make the kind of claims you're making, or you are making it. So why does the real assumption not work? Okay. The reason the realist assumption doesn't work is because it leads to these mutually exclusive causal claims. So I've shown the slide to 2 people before and they're like, well, what is going on? Okay, so I'm just gonna and I'm trying to change it, but I'm sorry, it's the best I can do. So this is 2 formulations of the argument if you believe the realist assumption as a premise. The first one says, we can classify behaviors effectively in terms of principles. If we can do that effectively in terms of principles, that must mean that the baby is cognitively using principles and therefore the baby is kind of cognitively is invoking these principles. And we can do the same kind of argument with a different classification scheme. In this case, Susan Carey's systems of representation. So we can effectively classify behaviors in systems of representation, but if we can effectively classify that, that means the baby's kind of invoking it implicitly. Therefore, the baby's using the system of representation, or the system of representation is playing a causal role in producing behaviors. And these conclusions are mutually exclusive. I can also add Nunes's kind of version of this. And if you were like, and if people have trouble seeing them, which I presented before or talked about this before, and we can get that in questions, so I won't spend more time on it right now. But the main idea is that they're mutually exclusive, and that makes a realist assumption implausible. Now, there's a couple of ways you could try to quote-unquote rescue the realist assumption. I'm not going to go into them right now in a lot of detail, and if someone has specific questions, we can go in questions. But the 3 kind of solutions are the following. The first attempt could be, well, the way I'm treating it right now is like all of these are on par with each other, but surely they're not on par. Maybe there's like one of these theories is genuinely better at classifying the evidence than the others, and the claim I want to make is no. It's not, because all of these accounts can subsume more and more evidence in their systems of classification. Because all they're doing is applying the systems of classification to any new experiment. It doesn't really actually better. There's no kind of metric for which you can say it's better. The second attempt is that one of them is more intuitive. Intuition can be really great in lots of things like ethics. It's not really great if we're trying to uncover cognitive mechanisms because they don't have to cohere with that. And the third solution, which people get excited by, is non-behavioral evidence. Like, okay, sure, my whole paper is about behavioral evidence. What about neuroscience? And things like that are increasingly getting integrated with developmental psychology. And I don't want to deny that outright. Like, I think there's things you can say, but I don't think it's clear. Like, for example, here's a question. What would be neuroscientific evidence that a child is implicitly invoking principles? Like, what part of their brain has to light up? What specific neurons have to fire for us to validate implicit invocation? And I'll talk about this more if people have questions about this later. But the brief idea is these are almost explanations that are different in kind, the kind of cognitive style explanation, and it's difficult how they're going to triangulate. Okay, so the consequences of rejecting the realist assumption. So this is an excerpt from the paper where I said denying the realist assumption means denying that we can infer underlying cognitive processes from advancing effective systems of classification, and it means giving up on the project of uncovering specifically the cognitive architecture of children, adults alike. And at this point, people get really scared because it makes it sound like this is a rant against developmental psychology, which it is not. The uncovering of cognitive architecture is a very specific subset of the kinds of explanations we see in psychology. They're very pervasive, but they're a subset. And what we get, actually, which I think is the use case, which we do see, is the following. Instead of that, we focus on capturing useful behavioral regularities or uniformities. So unlike speculating about the underlying cognitive mechanisms from observing behaviors, focusing on regularities means limiting our inferences to behavior themselves. right? And again, this doesn't mean denying that there are those processes, it just means epistemically we're not warranted to infer upon this. So what is an example of a kind of behavioral regularity, right? So I like to do this kind of case example of dyslexia, which is in the second case, right? Because one picture is that dyslexia is used as an example a lot in the literature to talk about it as a useful kind of system of classification that's helped us a lot in performing successful interventions. Now, one kind of view you could have is the only reason we were able to do that is because we uncovered the cognitive architecture of children and we find out how dyslexia functions, and by doing this we're going to get rid of that. But the argument I want to make is that's not true. If you look at case studies like dyslexia, the way we're able to do that is just by being more sensitive to behavioral divergences. So we start, for example, with students who are not able, or students who get the spelling of words wrong, and there are consistent ways in which they get those wrong. Okay, we call that dyslexia, for example. And then you're like, oh, and now to understand it deeply, we have to create these kind of theoretical accounts. No, you don't. The next step you do is you look at that, and you notice that certain kinds of interventions work with some of them, certain kinds of interventions don't work with others. So then you refine your classification system, and you make distinctions like somological dyslexia versus not, and you can do this iteratively, right? So one thing that it gives us is basically in the cases of interventions, I don't think this is a problem at all. But I want to point out a worry, which is, I think the main motivation, I think, for the paper, which I'm spending 30 seconds on, which is that I think that speculation about children's cognitive architecture gives us a kind of false confidence that is kind of terrifying. In the developmental psychology literature, people often talk about Piaget. He's the butt of many jokes, right? Because people are like, Piaget had this kind of bad project, and he did poor experimental work that justified children as like non-agents in lots of ways. And my argument is it's not actually his poor experimental work, I think that was the problem. It was the idealized cognitive architecture part that was the problem, right? If we treat those studies as kind of observing behavioral regularities instead of pointing towards this kind of structure of cognitive thought, we don't get into the same kinds of worries. And I think we allow for kind of pluralism and explanation when we're thinking about children. Cool, I will end there. Yeah, absolutely. Yeah. Oh, cool. Any questions? Yeah.
Thank you so much for the presentation. I see this is like an anti-theoretical thrust. So I'm just curious, do you think there is a space for theory? And how would you describe that differently than this?
I think so. I think the problem is not theory, but it's specific kinds of ascriptions of cognitive processes that produce behaviors. For example, we can stick with it. I think you can have a richly theoretical account of dyslexia that focuses on behavioral divergences, behavioral regularities, interventions, how they may work, how to think about designing the right kind of interventions. Maybe that's not theoretical enough based on your question. But yeah, I would say, I don't know if that answers it satisfyingly, but it's really, I think psychology is such a big umbrella, development psychology is such a big umbrella, and I don't want to come across as saying all of it is I think this argument is probably better suited to talking about certain kinds of inferences. And I'm always careful to be these kinds and not other kinds. And I off the top of my head, there could be ones that look like this but aren't quite like this, right? That would be theoretical, but okay.
I think these are two questions that are really the same question.
Right.
So the first is I'm trying to figure out if there's anything specific about developmental psychology that's specific to the argument. Because the argument sounds to me a lot like the Van Frossen versus hacking instrumentalist realist debate. So
Yeah.
We have a predictive model.
Yeah.
Half the people think that gives you real structure, and then Van Frossen type people are like, no, that just gives you useful regularities. So I'm trying to figure out if there's something about this. Looks like that argument applied to this space, and I can't see if there's any specific about it.
No, you're right. Okay, so two things I'll say. One thing, I footnoted Van Frossen in the paper saying that this is a kind of application of Van Frossen in this context, but there's an additional constraint. Because I think Van Frossen's argument is really, really strong, and I'm kind of limiting it to the psychology cases because I think there's sort of, these two slides speak to what you're saying. So the first kind of, I use the quarks example over here, right, which is one kind of version of what you could think I'm saying is that, it's really about indirect evidence of a certain kind of phenomenon, and we don't have good indirect evidence to like postulate this kind of rich like cognitive process. It's not good. I'm really focused on these kind of claims. I didn't really talk about it done in the presentation, but the literature really relies on, first of all, it's like an action that we do, and we do it sort of implicitly, unconsciously, and I think that gives a certain flavor to it. So an example I use in the paper is why it would be different. So for example, let's say I give a kind of explanation of how your hypothalamus works or something like that, right? The reason those explanations are not cognitive explanations, even though I'm describing a set of procedures and stuff, is go and say your hypothalamus implicitly kind of regulates so-and-so, or it unconsciously does so-and-so. So I think there's something about this kind of implicit cognitive unconscious, and how central it is to the explanation, that I think makes it more troubling than just kind of talking about a direct explanation more broadly. That's the first thing. And I think the second thing is Van Frossen's account, as I understand it, is often talking about potential, like underdetermination in general, but it's often like, in this case, we have actual alternative theories, right? As opposed to potential underdetermination, where you could generate more theories. We have existing theoretical accounts. And I think that makes it stronger in this case.
Yeah, this is just to the second part. Can you go to the contradiction slide?
Yeah.
Yeah, so my question is, from the fact that the realist assumption generates two contradictory claims, why are you saying that this leads you to reject realism versus saying that realism assumption simply underdetermines which is correct given the current evidence state?
Oh, no, for sure. So I would say that, okay, so I would agree with the latter. So I would say that we should, but to me, to reject the realist assumption means to reject, okay, so maybe there's an idea about realism versus the realist assumption, and this is maybe an important distinction to make. You're right in the sense that this does not justify rejecting realism about cognitive mechanisms, but the real, and full disclosure here, I sent this paper to someone, they didn't like the word for the very similar reason, so I changed the name. And in the new paper, it has a less sexy name, psychological anchor, and not the realist assumption. But part of the idea here is that the realist assumption is saying that if we can effectively classify certain behaviors into these schemes, then that's sufficient evidence that they play a causal role in producing the behavior, which is a much stronger version of like what realism entails. Yeah, basically, it's a sufficiency idea there. Sure.
Let me say something that I think might help with this question. One of the things you're claiming is that, okay, the three alternatives we are entertaining, number one, they're real alternatives, so it's not, well, there could be something different, but also that it's not obvious what could count as evidence for one or the other. So it's not as though, just do more eye tracking or track the ears as well as the eyes or whatever it might be. But if the way these things are set up, since they're all about behavioral evidence, it's not that you're going to get something about non-behavioral evidence that will be different in these cases. Now, I mean, you're not saying you can never get anything that's going to get behind my behavior to whatever's going on, but the structure of the argument seems to be such that it's, you're saying, yes, of course these things have a clause. You speculate A, you speculate B. Now what? If we don't have a crucial experiment, we don't have a, thumb on the scale experiment or anything. So the thing that you need would be something that could favor one of these things over the other. And you're saying, as yet, it can't be purely behavioral, because I'm just giving more behavioral stuff and it'll still be behavioral at the end of the day. And it can't be purely neuropsych, because that won't tie it to behavior well enough. So what else do you have in mind? And I think that's actually a a very important question here, because it really isn't clear what, what more could you want that you could even tell me, never mind figure out how to get a baby to do it.
Justin, did you have a question? Or you want
Yeah, I had a couple questions.
Okay.
If that's okay. I really enjoyed the presentation and even sympathetic to like the more humbling of how we think about the cognitive architecture of children and adults. I was wondering, thinking about the last presentation, like to what degree is it a rejection of like a psychological anchor versus like just a rejection of like there might be multiple psychological anchors in the way that there are multiple ways to describe the social ontology of exploitation of higher education. That the individual is one way, that the policy is one way, that the norms are one way. And so it's a different way of like producing, I think, a humbling or like a sort of more tentative nature without rejecting that these might be real things that in a networked system like the brain just happens in multiple ways. And I had a couple of others, if that's okay.
Sure,
Should
I
I
also
stop
wanted
there?
my ask a
Could we
question,
use the last few minutes to maybe collect questions? Maybe we
Yeah,
can respond,
sure.
we can respond later.
Yeah, the other one was just, I have a worry and then a pushback as
Okay.
well. The worry is that it feels like it's also a sort of retreat to behavioralism, which is, most people would think of it's a little bit of advance to go from behavioralism of the 60s, 70s, 80s into kind of cognitivism or like wherever we are now, which is something mixed, I think. But it seems like you're pushing back towards behavioralism, which is worrisome. And I think along with that, you mentioned that it doesn't have any concern for generating interventions, but I'm not sure about that because I think the generation of interventions relies on theory.
Yep.
And so it's kind of a smuggling back in of the theoretical and also the kind of at least tentative causal explanations for things, even though they may have then become behavioral interventions.
Thank you.
Fantastic. We do have minutes. I'm going to throw in also another
Yeah,
question.
absolutely.
I am actually worried about the characterization of how causal claims are made in cognitive psychology,
Yeah.
because I think there's a missing element that it's not just, it doesn't just happen based on classification, it also happens based on controlling for other variables that are not the cause of such happening. I think that's actually at the base, and that's why you have randomized control trials, and you have a similar population, so you're like comparing apples and apples, and it's not something else. Now that doesn't mean that the part of the argument that stands on in the classification doesn't stand, because you could say, oh, well, this is actually not dyslexia, this is actually dialect interference. And so while you know that something is different, you control for the variables, you could still say, well, actually, what caused the difference, you could revisit with the theory. You could say, oh, well, what caused it, we know there's a difference, but I'm going to revisit this, I'm going to redo this, and maybe actually there were two variables interacting with one another that caused it, and maybe I want to control for this other thing. But I think that would deepen the discussion if you account for that.
Okay. Thank you.
Thanks, everyone.
All right, thank you.